Oh, yeah.
Good morning, afternoon, evening, whatever it is. They just talk?
Black marker because it means you have a seat.
Oh, okay. I brought some black ones and blue ones.
The ones.
What's that? I never have for BYU baseball. I could. I've got my pass will get me in, but
I mean, I've worked the baseball games. So
what do you do at the baseball
I'm a
game?
scoreboard operator, so I'm not gonna be on the field.
No. What I want is the scoreboard operator for basketball or football. But sometimes I'd like him to speed it up to double time and get it over with. You know, when it's obvious who's
Yeah,
going to win.
when you see it, you're like, this far, we're kicking in.
Like high school games, when one team gets 35 points ahead of the other, they use a running clock for football.
Yeah.
Nobody's gonna come back from 35 points down.
That was a tough one.
Okay, I sent the final exam over to the testing center this morning. So it's there for you. You won't go over there and find out it's missing. You're gonna have to take the exam. And which means it can't be changed. I'm not, you know, it's it is what it is. There are 6 questions, and they're based mostly on the stuff we've talked about since the midterm. So what have we talked about since the midterm? We talked about traverse adjustments. We talked about curved lines, mostly highway curves. We talked about public land survey system and how you divide the land up into rectangles. We talked about calculations of volumes, and we talked about how to mark a stake. That's basically it. But you still know how to calculate. You need to know how to convert between latitudes or calculate latitudes and departures, how to calculate bearings, and how to convert between bearings and azimuths. You still need to know that. So if you can do those things, if you can do the homework problems, you can ace the exam. That's the bottom line. Because there's only so many things I can make up about, So the best thing to study is your homework problems. If you're having problems with those or understanding them, now's the time. Or tomorrow, I'll be here again tomorrow. I'll be here during the class times tomorrow, 10 and 3. If you want help, I'll be in the classroom. Come. We'll go over. So that's the plan. Again, 6 questions. There's plenty of room on the test document to do your answers. There's blanks to fill in. You can show your work. If I can figure out what you did and you don't get the exact right answer, you get most of the credit anyway. Please know that I got 116 of them to grade. And I don't have sear stones to translate what you did. I don't have any. So if you want to show your work, do it in some logical order that I can follow. Otherwise, I'm going to just say, oh, Dawson didn't know what he's doing. He didn't get any points for that. So, all right, where do you want to start? Who's got questions about what? Sure, which kind do you want to run? No.
I know.
That's a trick question. We only talked about one. We talked about compass rule adjustments, right? Okay. Steps. Number 1.
A black marker right here.
You want me to use black?
Yeah.
All right. Number 1. Calculate the closure error and see if you made that. It's like the the one problem on the midterm, calculate the closure error. So if I have a traverse like this, I start at A, and mathematically I end up back at A prime. So here's A prime. You need to calculate this closure error right here and see if you met the specs. You know, that's a distance. A closure error is simply a distance. Now, it's not a direction, it's just a distance, okay? If you met the specs, then you're allowed to go to step 2. If you didn't make the steps, you go do your work over, okay? So I suppose for an exam, you're not going to go do the work over, so you're going to probably meet the specs, right? Okay, and we do that by calculating the bearings of each of these lines. You know, we've got interior angles here. And so we have to calculate the azimuth and the bearings of each of those, and the latitude and the departure, add them up, and you'll get some error here. And the error is simply the square root of the latitude plus the departure squared. If you add them all up, you get back here, they'll add to 0. If you're perfect, the latitude and the departure will each add to 0. But if they don't, your error is the latitude difference squared plus the departure difference squared. And remember, when you do this, calculate the azimuth of each one, that the forward azimuth is always equal to the back azimuth plus the interior angle. So if I start here and I go along here, and then I say, okay, this is either known or assumed. For most of the time, we'd assume it's just 0, because that's a good place to start. So back azimuth just looks the other way. Add this angle, gives you the forward azimuth. Go to this point, back azimuth, 180 degrees difference. Add that, gives you this azimuth. And then you can convert the azimuths to bearings and calculate the latitudes and departures fairly easily. Right? Okay. That enough for step 1? That's the pain in the butt step, okay? All right. Step 2. Balance the angles. The sum of the interior angles has to equal 180 times n minus 2. So in my case, with a 5-sided one, 5 minus 2 is 3 times 180, 540 degrees. They have to, the interior angles have to mathematically equal that. Okay, so balance them, and usually we do that just equally. If they've more than 5, in our case, more than 540, you subtract an equal amount from each of your interior angles that you measure. If they're less, you just add an equal amount. There are some cases which are beyond the scope of this class, we would do it not equally, but so just balance them by an equal amount to each one. The idea is that it's just as likely to make, you're no likely to make a greater quantity error in a large angle than a small one when you're reading your total station or sighting on the prism. So you just assume, because remember, we've already met our specs here. You just assume, and so we're going to balance them equally. Yeah. Number of sides, number of points, whatever you want to say. Yeah, number of sides. Right.
Would it be 5?
5 minus 2 is 3 times 180 is 540. And I mean, it could be, you could have a traverse that's got 742 sides. You don't want one, do you?
That sounds like
Guess what? He does. He just raised his hand.
When there's 5 angles,
Yeah,
you're gonna divide by 5, right? So you're gonna apply by 5 to change each angle.
well, let's say that I end up with 500, and if I add these up that I measured, let's say I ended up with 540 degrees, 30 minutes. So I got an error of 30 minutes. So I would just subtract 6 minutes from each one, whatever they are. They're not equal. You just subtract an equal amount from each one. You okay? All right. All right, step 3. Okay, step 3, you do this over, but instead of using the angles that you measured, you do it with the balanced angles that you calculated here. So every one of these will be a little different in direction. So it's the same thing. Forward azimuth equals back azimuth plus the interior angle. You go around it again, figure out what called the balance bearing then of each one of these sides. Okay, step 4. Use the balanced bearings and measured distances and calculate the latitude and the departure of each side. So I'm going to calculate the latitude and the departure of each side based on my new bearings after I balance the angles. Okay, step 5. Add the departures and add the latitudes. Okay, so these are going to sum to something besides 0. If you were incredibly lucky and they did sum to 0, you're done. You don't have to do anything else, but they won't. So we're going to say, okay, so this determines the error on each one. So what I would say then is that, say I sum this to 0, and this one's for departures and the latitudes. So my departure sum equals that. My latitude sum, let's make it easy, equals minus 0.20, like that. So this is my error. This is my error. And then step 6, you distribute the error proportional to leg lengths. So I would say, so if this ends up at 0.15, that means I've got too much. I've got too much departure, right? So every one of my departure corrections will be a minus. This one's a minus, so every one of my latitude corrections will be a plus. And that gets me back to 0. So we distribute in proportion to the leg lengths, and we just say that my correction to a line is equal to my total error. And I guess I could say total error times -1, because if my corrections are going to be negative here, so I could say total corrections -1 times the leg length over the total length. Step 7, So then I get a correction for each one. I apply those to the ones I calculated here. And now I have latitudes and departures, which will sum to zero. If they don't sum to zero, you made a mistake somewhere. And then you can use these the corrections you get from step 7 to calculate the coordinates, your adjusted coordinates for each of the points on the traverse.
For the correction, the total error, what are you finding the total error by?
That's this. Oh, what am I well, you just change the sign, -1. That's all. I mean, if I got a total error 0.15, I want corrections of minus. If I got minus here, I wanted corrections of plus here. So what I'm doing is taking this and distributing amongst all the legs based. So each leg, maybe I better say, each leg correction is equal to the total error, this, times the length of that leg divided by the total length. That just distributes it proportionally amongst all of the legs of your traverse, whether there's 5 sides, 4 sides, or 742 sides, right? Got it.
So then, instead of like before where we would divide it by 6, 12 by 5, and then change all the angles for the leg, we times it.
Yeah, the leg angles are balanced equally, okay? Latitudes and departures are adjusted proportionally to the length of the leg they apply to.
If we wanted to do that with the angles, it would basically be the same.
Don't do it with the angles. Just wipe that right out of your brain, okay? Just don't do it.
So what's the point in finding this first closure error? That's just how far you were.
We want to know if we have a closure error that doesn't meet specs, we're not allowed to even do the adjustment.
Okay, but I'm assuming the test is gonna meet the specs.
I'd like to be able to give you the test, say, oh, this didn't work, go out in the field, do it over. But I can't. I don't think the testing center people would understand that very well. Man, that'd create a fuss. That'd be fun. Hey, get out of my way. Move, you're in my way.
Are those is that the 0.15 for the departure and the -0.2 for the latitude? Are those the like caps at which you can be at? Or?
No, that's just whatever this step 5 adds up to.
Okay.
Yeah. I mean, again, remember, if I'm, let's say this is north, say I don't have any departure, right? I've got some kind of latitude. I'm going straight north. Here I would have, if I drew this right here, I have a latitude that's a plus, and I've got a departure that's a negative. And here they're both negatives here, you know. Anyway, if you close perfectly, they all have to add up to 0 and 0. If they don't add up, that's the error. And you know, you have a spec for your job, 1 part in 10,000. If you've got 1 part in 8,000, you didn't meet the specs. You do it over. You go do the work over, which is really unlikely to do on an exam. But
So the specs, just don't know that we didn't do a mistake. What are the specs again?
it's generally a ratio of precision, like that problem on the midterm. Your accuracy ratio has to be 1 in 10,000, or depending on the order of surveying. For some things, 1 in 1,000 is fine, but most of the time it's like 1 in 5,000, 1 in 10,000, sometimes even 1 in 100,000. And that's called a nightmare.
So, could you show, so how would you get like that departure one right there? That's just
This one,
far off.
this one, I would take all of the latitudes and departures, all the latitudes I calculated here, add them up. And the error is how much difference they are from 0. That's all.
Oh, okay.
I mean, I would, calculate the latitude departure of each one. And then I would just put them in a column, add them up. If this is not zero, it's some kind, I put latitude, it's here. That's all. Yeah, that's the error is how much different it is from zero. Lauren? Because if your survey work was so bad that you can't meet your specs on closure, you got to do it over. What you're asking me is you're gonna have to, are you gonna have to do that on the exam? Is that what you're asking me? You want me to tell you the answer? You wouldn't ask the question if you did, right? What do you think? All right.
So we start on number 4 then for the year, or number?
No, start on number 2. Yeah.
You'd have to start here. Balance the angles. Who else had their hand up?
Just to make sure, so that I don't go crazy during the final. It will equal like 0 perfectly, or is there some specs that we'll be able to think about? And so, and if there are those specs, would they be less than how many significant figures?
Well, the specs would say, did it close within 1 in 10,000? Or did it close within 1 in 5,000? That comes to 1 in 4,999, you didn't meet the specs. And then you can't work the rest of the problem. So Lauren's going to tell me that I'm not going to ask the question that way, right?
I really want you to, but I can just write, it doesn't mean spec, I'm not doing this.
Yeah, right on there. It doesn't meet specs. I don't have to do the rest of this. Anyway, that's the steps to do a compass rule. And then once you know the latitudes and the departures from this step, then you can just say, oh, okay, I've got an adjusted latitude from A to B. So I can say, all right, I know the coordinates here are 1,000, 1,000. I add the latitudes and departures, that gets me to here. I add them again to get to here and here to get here. When I get back, I should come out, if this started at 1,000, 1,000, I'm going to come back. There'd be no difference. It's 1,000 and 1,000. That means I picked A up and I moved it over here. In the process, I moved every one of these slightly. Compass rule adjustments are not hard. They're just a pain in the butt. Yeah.
Can you give us a broad list of the different type of problems we're going to be tested on? Just so
I thought we just did. You got to know how to calculate bearings. You got to know how to calculate latitudes and departures. You got to be able to convert between bearings, azimuths and bearings. And we've talked about compass rule stuff. We talked about public land survey. We talked about volumes. We talked about staking. What am I missing, Brian?
Circle.
Oh yeah, we talked about how do you stake out curved lines.
Okay, just to double check, calculate bearings,
You got to do that.
latitudes, departures.
Yep.
What was the third? I missed the third.
Got to be able to convert between the azimuths and bearings.
Okay. Then it was compass rules.
Compass rule,
Public land survey.
public land survey,
Curved what?
curved lines.
Okay.
What we talked about highway curves, right? Yeah. Curved lines. We talked about how to calculate volumes. And we've talked about how you mark and use stakes. I think that's it. That covered everything since the midterm, I think. Am I forgetting something?
And the things from midterm or midterm 1 is more converting azimuths and bearings and latitudes and departures.
Yeah, you got to know how to do that.
Okay.
So you said that's everything from the midterm. What about everything prior to the midterm?
That's latitudes and departures and bearings and azimuths and all that stuff.
With curved lines, is there gonna be equations that we need to memorize?
I told you, I don't memorize the equations and don't expect you to. Any problem that deals with with curves is gonna have the equations on the exam. Don't, yeah, don't memorize, well, you can if you want to. But I would spend my very limited brain power memorizing something else. Again, the standard is if I don't memorize them, you don't have to.
Can we go over, curve line statement?
Yeah, let's make sure we get everything answered about this first. You had your hand up again.
Do we have to know the exact size of an acre for the quadrants? Split in fourths?
Size of an acre.
Yeah.
Acre's an area calculation.
Okay. For the sectioning,
Well, how big's an acre?
I don't know.
Depends on whether it's a back tooth or a front tooth, I know. Acre's 43,560 square feet, but it's really 10 square chains. And there are 80 chains in a mile. So if you got a land dimension, you can do it in feet, divide by 43,560. You can know that 1 square mile, 640 acres, and go from there. You can do it in chains, whatever you want to do. Probably. I want to know how big the land you deeded me is. Because I ain't paying you if it's less than, right?
8 chains in mile, how many chains in an acre?
You can't, there's 10 square chains in an acre.
Will there be a cut and fill problem on the final?
A cut and fill problem. What do you mean?
Like,
Well, there's volume calculations. Yeah. We talked about let's see. Somebody asked me about curved lines first. Should we do that first? All right. I guess I can draw one. I brought the one on the computer, but I don't know how to run this thing in this room. Where did I put the black one? Okay. So the curves we talked about were all circular curves. We didn't do spirals. We didn't do multi-centered curves. We just did simple center, one single center circular curves, right? Okay, so I didn't ask any questions about spirals for more reasons than one. First reason is I'd have to sit down and figure it out myself, okay? So we have a straight line like so, intersects another straight line like so, and we have a curve here that has a center point and has a radius. And this angle is the deflection angle, delta. That's the amount of change of direction. And just by geometry, this angle is the same. It has to be, always, okay? Then we have some things we need to know. We have a station here. This is called the PI, point of intersection. This one over here where the curve starts, it's tangent. The radius is always a right angle to the tangent here. Where it starts is called the PC, point of curvature. Sometimes you'll see it called the VC for beginning of curve. Okay, we have a station over here called the point of tangency. Sometimes you'll see it as EC for end of curve. So point of tangency just means it gets back to a straight line, okay? Then we have the length of the curve here. That's the length along the arc. And we have a chord distance, which is just the straight line between the PC and the PT. So the things you normally have to calculate are the tangent length, which is the distance from here to here, which is the same as the distance from here to here. It's always the same, okay? And you need to be able to calculate the length of the curve, And that's not what I mean. Oh, and then we have that thing called a degree of curvature. Degree of curvature, which all the degree of curvature is if I walk or drive or whatever 100 feet along this line, along this curve, how much do I change direction by? So let's say I have a degree of curvature of 10. That means for every 100 feet I go along here, I change direction by 10 degrees. That's all that means. And you can calculate anything you want to know after that based on the equations that I don't need you to memorize, okay?
So yes, we don't have to memorize the equations, but do we have to memorize all the point of curvature?
You gotta know what they all mean. I mean, the equations don't tell you much if you don't know what they mean.
Okay, but should we be able to like point them out and like draw them out on a?
Draw them? No, I'm not having you draw it. Well, I did. There is one problem, you have to draw something, but it's not this one. So now I'm not answering your question. What if I
Like put the point of curvature in the correct spot, put the point of tangent.
yeah, I mean, the common things you have to calculate is, oh, okay, I know the station here. Cause you know, the designer gave me that. He goes out and he does this and this and this, and he tells me to put a 10-degree curve in there. So I gotta be able to calculate this distance, the tangent, so I know where this starts. And where it ends, and I need to be able to calculate the length, that kind of thing. That's the basics. I mean, there's lots of other crap that goes with these, but we didn't talk about them all.
So the degree of curvature is different than your delta, which is your degree.
The degree of curvature has nothing to do with delta, nothing. Yeah,
Is delta given to us, or do we have to calculate that?
with delta, well, I could figure out how to do it backwards, but commonly the specs are, okay, here's a tangent that goes this way. I want the road to go this way. Eventually, I want it to go this way, okay? So what's the delta in between? So delta's a given.
I remember for that lab, you had to do like, normally you do stations every 100
Yeah,
feet, right?
yeah.
So remind me how you find like what first point you put in, because
Well, okay, I'm gonna stake them out in whole stations, right? Every 100 feet along here. Well, my first one's not gonna be a whole 100 feet unless by some weird, this is an even station. It won't be. So it's just proportional, but I can tell you that's more than the test problem asks for, okay? I have to stop and think about how to do it every time well, I guess I should expect you guys to stop and think about how to do things too, but I just decided that was gonna take you too long in the testing
that's
center.
what the lab does.
Yeah, yeah.
So on this question, will be expected to find L and C?
Well, I don't know, but you gotta be able to know how to, if, you know, you're the surveyor and who's a highway engineer in here? Anybody? Okay, he goes out and does this preliminary design for road and says, okay, I want the road pointed towards Spanish Fork. And then I want it pointed towards Salem. And so there's got to be a bend there, and the bend is this much. Okay. And he tells me, well, this is going to be at station something. Then I can calculate based on that and the spec for degree of curvature, which is usually based on design speed, which you'll learn about when you take a highways class. I can figure out everything else I need to know about that curve based on the PI, the degree of curvature, and the delta. I can figure out everything else based on those three things. And then I can go lay it out. I can do it with a GPS. I can do it with total station. If it's a short curve, I can do it with a tape. I don't think I'm going to do it with a tape on a freeway, but on a city street, I might. I've done that lots of times.
Delta, the degree of curvature and
the PI. You can solve anything, you can solve anything with it. You can always, even solve the deflection stuff. But that was just too long for a test, too long for a test. I'd have given you one problem and it would have taken you the whole, an hour. Well, it would take me an hour to do it probably from full.
Suggest about the same amount of time as last.
Yeah, maybe a little less. There's only 6 questions on this one. But, plan on a couple hours. But you can sit there and torture yourself as long as you want. I thought about having a time limit. And it's like, I'm not going to say it nicely. I'll just say it. Like mercy killing. If you don't know how to do it, let's kill you and get you out of there. No,
Is it just in the testing center?
just in the testing center. It opens when Friday's the first day of finals, and it goes until the following Wednesday. You can go over there any day between except Sunday. I don't think they're open Sunday. So
You know when the first exam will be graded?
it's been graded for a long time.
But there's nothing.
Yes, there is.
Final?
Part 1?
Oh, Ryan, when you guys gonna have part 1 grades entered? Tomorrow. Well, but what they did for part 1 is they set up a rubric. If you're off by this much, you use 1 point. If you're off by this much, you lose another point type thing. And so it takes a minute to go through and do that, but why is that? Because you were off by this much
Yeah, probably.
or this much? Somewhere in
Probably
between.
a little bit of both.
Yeah, well, was that next? Is that the next question I gotta ask? All right. Anybody got more questions about curves? Okay, there's 2 ways. There are many ways, but we talked about 2 ways to calculate volumes. One's the grid method, where I have either on an excavation or a stockpile, I go through and I just set up some kind of a grid. And I measure the elevation at every grid point, both before and after the excavation or before and after somebody builds a pile of gravel, right? So then what I want to know is the difference. So let's say that I measure this and it's 104 and it's 104 before the excavation, 105, 117, 120, whatever it is. And I'm excavating down to say 100. Then I know at this point I went down 4 feet, right? Here I went down by 20 feet, 117. So the average depth of excavation on that is just add those up. So I'd say 5 plus 4 plus 17 plus 20, 37 equals 46 total, right? And divide by 4, so I get 10, 11 and a half times, if I got a 50-foot grid, times 2,500, that'll give me the amount I took out of the material I took out of that grid, right?
Okay, so you just add up the,
And then you add them for every square. But when you do the calculations, if I'm doing this square and this square and this square, that point applies to 4 squares. So you can go through and do every one of them like this if you want to, but I wouldn't. I would just say, let's number these like A, B, C, D, 1, 2, 3, 4. If I was on that one, I'd say, what is that? That's B2. I have a 20-foot excavation and it applies to 4 squares. So I put that in there. times. And then this one over here would apply to 2 squares. So I would just multiply this one by 2. And then I add all of these up down here, whatever the sum is. And then I'm going to divide it by 27 times 4 to convert from cubic yards. This is because, I'm averaging 4 out of all here, and the 27 is just to convert from cubic feet to cubic yards, which is the normal pay quantities in cubic yards.
Why are we multiplying this?
Because I said it was a 50-foot grid.
Oh, okay, so it's average.
Yeah, I mean, if it was a 30-foot grid, it'd be 900, right? Isn't 50 times 50, 2,500?
Basically, just take all the numbers. Assuming 100 is the baseline, subtract everything. Based on
Right.
the amount of squares you had, add it all up, and then divide by the amount of squares, then multiply by the area.
Well, no. I would take my depth of excavation times by how many squares that a point applies to.
Where are you digging to on this specific?
Down, I said we're digging down to 100, elevation of 100. Okay,
Okay, so it's just that one square and the 4 is the amount of.
the 4 is the number of squares it applies to.
Okay, so B3 17 times.
Yeah. Right.
Once you apply your total.
What's that?
You need to divide that by.
108, 27 times 4. Yeah. The 4 is because it's, every point is 1/4 of a square. And the 27 is to convert from feet to yards.
So as long as we're correctly determining how many, like squares that single point is influencing, it just comes down to the sum of all of the points and dividing that by.
Yeah, I mean, supposing I have one down here. So let's say this is 110. That applies to 3 squares. So when I get to C2 in my thing, I would say 10 times 3 is 30. Because this one only fits for 3 squares. Yeah.
And so if you plus all those together, divide by how many squares, you get like the average.
No, you don't divide by how many squares. You divide by 4.
I didn't mean squares, I meant how many you can, like, B2.
You just add this column.
Divide by
108. Assuming you're converting from cubic feet to cubic yards. I mean, the 108 is just 4 times 27. So the 4 is because each one of those points is the 4th, basically has the weight of a 1/4 of a square, right? And the 27 is, that's just the conversion factor from cubic feet to cubic yards.
I'm having a little bit trouble remembering, how do you calculate how many squares the points apply to?
Just look at them. Okay, if I'm not excavating here, I got 1, 2, 3 squares to this point. If I'm out,
It's all the squares.
yeah. And if I'm out here, it's only, out here, it's only 2 squares, right? If I'm down here, it's only 1 square. Yeah, that's it.
So just to make sure, it's like after you divide it by 108, that's just your answer.
That's the answer.
By the amount of points you have, then you're trying to average.
That's why you did it this way. Just add them up And, I mean, you know, if you divide by 4, you get the answer in cubic feet. But generally, the contractor is gonna get paid based on cubic yards. I don't know why, but that's just how it is. So just divide by 108 and you got the conversion built in. What is staking? Well, how do you mark? It's like the homework. How do you mark the stakes? You offset to what, cut or fill, that type of thing. But you want me to draw some or? Okay, let's look. Everybody through with this? Can I erase this?
When will the homework 12 be graded?
It's not due yet, so we're just going throughout it.
Okay. Thank you.
That's right, it's not due yet. Till tomorrow. What's that? It's due tomorrow.
And with like the abbreviations for the station, will we be given?
Okay, you have to know what this means. The big O, you gotta know what this symbol means. You gotta know what this means and what that means. Other than that, I mean, you know, but supposing the question says, I got a hub here and its elevation is 104. And I want my top back of curb to be at 100. So my design elevation for the curb is down here at 100. So I mark my stake like this. Whatever the offset is, say 3 feet to the top back of curb, cut of 400. That's it. And if it's a sewer, you do have to put the cut and the fill to both the rim and the invert.
Don't, we never have to have elevation.
No, I only asked for the front. Didn't ask for the rear on the homework either, did I? Okay.
Is there any homework?
The ones we've done since the midterm. If you can do those homework problems, you can do the exam problems. The exam problems are not as extensive as the homework problems because, you know, 2 hours a week doing homework's a lot different than 2 hours one lovely day in the testing center. Who likes the testing center? Anybody near like the testing center? You like leaving it? Makes you feel good when you walk out the door? Either that, it makes you feel like you want to walk out the door and slit your wrists, one or the other.
Should have a plaque on the assessment center that says abandon all hope.
Yeah. Abandon all hope, ye who enter here. All right, what did we not cover?
I think it might have been week 11 or week 10 when we talked about satellites and.
Oh, I cannot ask any GPS questions.
Okay.
There's just nothing, I mean, there's just nothing on there that we can, you know. Yeah, I mean, I could ask you like we did the quiz, how many satellites does it take? I could ask you, tell me how they work, and I'd say, I don't know, how come you do it? You know, no, there's no GPS questions.
What kind of questions might there be about public land survey? Like, what township and ranges?
What's the township and range is, where it is, how you divide a township into sections, how you divide a section into parcels. That's it. So remember, from the initial point, townships are numbered up and down, ranges are numbered east to west. There's no zeros. The first one's number 1. And Then sections are numbered like the ox plow, starting in the northeast, back and forth. Then you get to 36 back down in the southeast. And then you take a section, you split it up into fourths or sixteenths or whatever it is.
How big is this section?
Section is 1 mile square. Yeah. There's 6 square miles in a township. 36 sections in a township. So each section is 1 mile square, 640 acres nominally. You know, they're not ever really, but they're supposed to be. Yeah, yeah,
It's like, there's like the northeast, would it be something like the?
Okay.
northeast of the
all right,
south?
sure. Well, I'm gonna use a different color pen in a minute. Okay. I start here with a prime meridian and a baseline. This is the initial point. Like the corner of Temple Square in Salt Lake City, right? Okay, and then I'm gonna divide that into townships like this, based on that. So each one of these blocks is 6 miles by 6 miles, right? And so I'm gonna say this is township 1 north, because it's the first one north, township 2 north, or township 1 south, township 2 south, or, and then east to west, I'd say this is range 1 east, because it's the first one east of the meridian. Or this one would be township 1 north, range 2 east. So townships go north and south, ranges go east to west. So I would divide that, you know, I can identify which township by that way. And I'd say in township 1 north, range 2 east, Salt Lake Meridian. That defines a specific 6 by 6 mile block of land that's unique to any, there's no other place in the United States described that way, right? Okay, so then I can take this, that block, and so here's my township, and I'm sorry my drawing's not real good. And I divide that into sections. So this is the 6 miles, and then each one of these squares is 1 mile square, and they're called sections, and I number them here: 1, 2, 3, 4, 6, 7, 12, 13, 18, 19, 24, 25, 30, 31, 36. So they're all numbered. Okay. So now if my land is in section 16 right here, then I could say it is in section 16, township 1 north, range 2 east, Salt Lake Meridian. Okay, so that defines that section. Again, that's unique to any other place in the United States. There's no other one that's named that. Okay, so then I can take section 16. So here's 16. So this is section 16, and I can divide it into what's called aliquot parts. So I can split it up like this. So this would be the southwest fourth of section 16. So I'd say the southwest fourth of section 16. And again, that's unique. There's nowhere else in the United States that is the southwest corner of section 16 Township 1 North, Range 2 East, Salt Lake Meridian. There's nowhere else. Or I could say here, let me write that better. This is the southwest fourth. And this is the north or southwest fourth of that. So this is the southwest fourth of the southwest fourth of section 16. Southwest fourth of the southwest fourth of section 16. Township 1 North, Range 2 East, Salt Lake Meridian. There is no other 40 acres in the United States that has that description.
Is when you're looking at the section numbers, is it always, so it's by the plow, right, the way of the plow, but it's always gonna be, it starts with that northeast.
Northeast corner. Yep, it always goes like this. I don't know why, but they did it, and we're stuck with it. There were some that were numbered like this. They went north, but there's a few of them like that in Ohio, but mostly not.
So if you have a smaller box in the section, you do the small fourth, like the bigger fourth.
Yeah, when you write these, it's always little to bigger to bigger to bigger. So if this is we said that a mile is 80 chains, right? Okay. So that means that this fourth right here is 40, and this distance right here is 20. So if I have 20 by 20, that's 400 square chains divided by 10 gives me 40 acres. Or I can say, I know that a section has 640 acres, and this is a fourth of a fourth or a 16th. So I can just say 640 divided by 16 is 40, same thing. Every section has 600, every normal size section has 640 acres because it's 80 chains by 80 chains. Did that answer your question, Lauren? You're sure? You're looking puzzled. That's no, I know for puzzle for you is normal, but whatever.
I'm assuming, like, I'm trying to jump into what you're probably gonna ask on my exam. I'm assuming we're gonna find acreage is what we're gonna be looking for. So I'm just trying to make sure that I understand how it goes from like a section to an actual acreage amount.
All you have to remember is a section is 640 acres. Okay, and then the aliquot parts, you know, they could be like this, a fourth of a fourth, or they could be half of a fourth, whatever it is. It's half of a fourth. It's 1/4 times 1/2 is 1/8. 1/8 times 640 gives you how many acres there are? 160. 80, excuse me.
So are they gonna ask us to label the section, or are they gonna ask us how big it is?
Yes,
Okay.
either or both.
Kind of a different topic, but what might you, are you gonna cover Mercator projection or any of those?
Oh,
projections that you
no.
talked about?
Yeah, I'm going to give you a math problem that says convert this latitude and longitude to state plane coordinates, right? Now, this testing center is going to say, well, you can't use your computer. It doesn't say that on the thing. That's how we did it. It was a website. No, there's no such thing on there. It would take me that's why there's a website, so I don't have to calculate that by hand. Okay, any more?
Just one more clarifying, so after we add up all the depths and divide it by the amount of, points, and then we multiply it by the area and square what comes after that? For the fills.
Add them up, right? Multiply by the grid size, divide it by 108. Assuming you're converting from cubic feet to cubic yards.
What was the compass rule again?
What's that?
What was-
Compass rule is that traverse adjustment we just did. That's a compass rule adjustment. We didn't do a transit rule, we didn't do a least squares. We did the simple one.
All right, so a section is the third magnification of that grid.
This is the one section is this, which is the same as this, which is some little bitty part of this. There's 36 sections in the township. We are sitting in township 7 South, Range 3 East, Salt Lake Meridian, as we sit right here. You walk over the other building, you're in 6 South. Because the line's right out here. I know they built the building just so I could confuse students. That's why they did it that way, but. Yeah,
You said there are 33 sections in a township. Should we know 30?
wh- 36.
Okay. Should we know that there are 36 or?
There are always 36. Well, there's weird ones, but for our purposes, there's 36. 99 point something percent of the world got surveyed with 36 sections in a township. Well, US world. I don't know what they do in Afghanistan. Any more? All right, don't make this exam harder than it is. When you see a problem, stop and think about it for at least 30 seconds before you start to work on it. It's a lot to ask of you.
I don't think very much.
No, come on.
Saying think about it for 30 seconds or like pray about it for 30 seconds?
You can do that if you